The last review video we have is going to be covering chapters 8 and 10. So chapter 8 was all with calculator, so you are going to see a lot of calculations. This was the chapter with law of sines, law of cosines, so let's start with the first one right here. It says we're going to solve with the law of sines, and you have to read the problem and make a nice picture to go along with that. So let's see. A man can see the top of a tower by looking up at an angle of elevation of 35 degrees. So the first thing I always recommend doing is drawing the ground. Okay? And then the man can see the tower. So just draw something that represents tower. He looks up at an angle of elevation. He then moves 50 feet closer. Okay? So I'm going to say the man starts here and he looks up at the tower. And the angle of elevation is 35 degrees. And then this is where he ends up, and this distance is 50 feet closer. So now he's here, closer to the tower, and he could see the top of the tower with an angle of elevation of 75. That makes sense. As you go closer, this angle here is getting a little larger. Okay, draw a diagram, and our ultimate goal is to find the height of the tower. But looking at this triangle, I don't know any numbers. I'm going to have to find something in this triangle, find something you don't want, to find something you do want. And the side that they have in common is this side right here, x. So that's what I'm going to go for. Let's find a bunch of these other angles. So you could do some linear pair, subtract from 180. This obtuse angle right here is 105. And then, of course, a triangle has 180 degrees in it, so this skinny little angle up here is going to be 40 degrees. Okay, and can I do law of sines when it's angle, side, angle? Yes. So I'll say sine of 40 goes with 50. And then let's do sine of 35 degrees, and that goes with side x. Okay? Then you cross multiply, and you say x is equal to 50 times the sine of 35 degrees divided by the sine of 40 degrees. Okay? And that's kind of how that works. I'm going to hold off with calculating anything yet. Let's go ahead and set up our next part. So looking at this right triangle, with right triangles you could do SOHCAHTOA. With obtuse, acute, or right, law of sines and cosines work. But since this is a 90 degrees, I'm going to say that this opposite and this hypotenuse wants me to use sine. SOHCAHTOA. Sine of 75 degrees is opposite h over hypotenuse x. I'm going to multiply both sides by x. Okay, I'm going to take this right here and I'm going to multiply that by the sine of 75 degrees in my calculator. Let's go ahead and give everybody a chance to practice their typing. Please hit pause. Okay, are you back with an answer of 43.10 feet? Okay. We did do a variety of word problems, so make sure you study all the different types. This is a very popular one. We also had the one where there's a bridge and looking down two things, and you didn't chop it half and half because the angles were different. But it's all on your note card, right? Okay, the next one that we did a lot was find the area of this shaded region. Okay, so the idea here is you take a circle, and if you go to the center, there's a central angle right here. This much area, that's too much. This part here is called a sector. And I know that we studied that in chapter 6. This is definitely on your final. You're going to take the sector, which is too much, and you're going to have to subtract the little triangle. And if you subtract the little triangular piece from that, then what happens is you get the curvy little edge right there, and that's called a segment. Okay. Be careful that you read the final and you find the right thing that's being asked. Okay. If the central angle is 70 right there, I could put that in the triangle, and I need that for the sector. And the radius is 13, and I know that with a circle, all radii are congruent. Okay, so the setup here is going to be pretty straightforward. There is a formula for sector, and it's 70 degrees out of 360. That's a fraction of the area, pi r squared. A triangle, let's go and subtract triangle. Since we know side angles side, I'm going to say that it's 1/2. And then it's side 13 times the sine of 70. And then type all that in your calculator at once. And the answer is 23.83 meters squared. Okay, seeing as how we did sector in 2 of our chapters, please be ready for that. All right, what else did we study in this chapter? Solving a triangle. Okay, whenever you solve the triangles, whether they're word problems or regular, make sure you look at it and check to see what information is given. This says angle side side. Angle side side. Uh-oh. When it's angle side side, we're definitely going to use the law of cosines. The angle will tell us how we're going to start. Okay, so if you're given a 42-degree angle, we have to start with the 5.6. 5.6 squared equals 7.2 squared plus, let's call this little side b, b squared. It's not a right triangle, so the formula is -2, and then one of each of these, 7.2 and a b, and it's cosine of angle 42 degrees. Okay, do you remember how to do this when the variable is squared and single? We can't just type it in our calculator. We're going to have to put this in descending order. Okay, it's a quadratic equation. So this is when we used our formula a lot, the quadratic formula. Cosine of 42 degrees. I would like to put the b at the end. And then 7.2 squared minus 5.6 squared is 20.48. Okay, we're going to go ahead and use our calculator for the quadratic formula program. And a is a 1, and b is -14.4 cosine of 42. Just double check you don't make any typos there. And c is 20.48. Okay. When you do the quadratic formula program with law of cosines, if both of these numbers are imaginary or negative, then you throw them in the garbage. If 2 positive answers spit out, then that means that this actually is 2 triangles. So this is when we had to take our paper and then we have to slice it in half and we have to draw the same picture 2 times. And one problem becomes 2 problems. Okay, this is angle B, angle A, angle C. Okay, so one of the answers that I'm getting from my calculator says little b is 8.21. So I'm going to say this one is 8.21, and then this triangle down here, little b is 2.50. Okay, when you're solving a triangle, you have to find all the missing parts. So little b was one of them. Measure of angle B was another. Measure angle C was the third. Okay, but not only do we have to do that one time, we're going to have to do that 2 times. Little b, measure of angle big B, and measure of angle C. Okay, and I already figured out that side B could be 8.21 or 2.50. Okay, now the good news is I just have to do one more equation, then I can subtract from 180 to find the final angle. And once you start with cosines, finish with cosines. Okay, otherwise you might turn it into another angle side side problem and then you're going to get the wrong answer. So I'm going to go for the measure of angle B next. If you want to go for measure of angle B, let's start with side 8.21 squared. Then we have the other 2 sides, 5.6 squared, and then just look right here to finish your law of cosines. -2, the first side, the second side, cosine of angle, oh I don't know it, capital B. That's the angle that I'm going for. Okay, and then this becomes just a straight up calculator. You're going to subtract this, and then you're going to want to divide by all this or use the fancy button in your calculator. And the measure of angle B is about 78.70 degrees. Watching me set this up and understanding what I'm doing and being able to type this and get the right answer are two different things. I need you to practice this and see if this is exactly what you get. So please stop the video and try that. Okay, and then we're just going to subtract from 180 to find the measure of angle C, and that's 59.30. Okay. To do this one down here, we're going to start with the same exact setup that we had, that green equation, except our side little b this time is 2.50 squared. Okay, but the rest of that law of cosines formula is all going to be the same. 7.2, 5.6 cosine of angle B, and you use your calculator, cosine inverse to find an angle. Cosine inverse, and I hope that you get 17.40 and 120.60. Okay, I have to be honest, this is a lot of work for one multiple choice question on a final, so I probably wouldn't say find all 6 things. It might just be find one angle, but there might be 2 answers. Okay, if 2 good answers spit out, then you have to say 2 answers. It might be no triangle. You just have to see. Okay, and the last chapter that we did was the conic sections. I know we just studied it, so I'm just going to go through one problem here with you. Okay, this was on the no calculator part. So to complete the square, I'm going to put x's first, and I'm even going to factor the 4 out right away. Let's put minus 24, but it's actually going to be minus 6x. And then, oh, it looks like it's going to be a hyperbola. Minus y squared. I'm factoring the negative out. So this is actually minus 4y. Okay, leaving some space. 16, you got to go to the other side. And now it's time to half and square. Half of negative 6 is negative 3 squared, and that's actually plus 9. Okay, but it's not really a 9, it's actually a 36. Half of 4 is 2, squared is a 4, but it's not really plus 4, it's actually minus 4. So let's go ahead and minus 4. 4 times x minus 3 squared. Remember, this sign right here will tell you what to put. It's a hyperbola, right? Y minus 2 quantity squared. 36 minus 16 is 20. 20 minus 4 is 16. And I'm going to divide them all by 16, 16, 16. Make sure you cancel these the right way. We had some problems on the quiz with that. 4 cancels with 1, and this is a 4. Okay, so the 4 is definitely in the denominator. Here, the 16 is just in the denominator, and there's a 1. Sometimes when you start to complete the square and you're dividing by a negative, then the negative here cancels out, and then who I thought was the transverse suddenly isn't. Okay, so the transverse is x. That means the hyperbola is going, okay, left and right. Let's see, what is the center? Now that you have the square all completed, we can answer some questions. So the center is going to be 3, 2. Change. Make sure it goes x and then the y. R sub x is 2 and r sub y is 4. Don't forget to square root them. Let's see. Focal radius, r sub f squared. When the hyperbola has a minus, I'm going to put a plus here. You have to square, or you could just look right there. 4 plus 16. R sub f is the square root of 20. Square root of 20, which is equal to 4 times 5, 2 radical 5. But that's about, let's see, let's go back to 20 to figure that out. 4 times 4 is not enough. 5 times 5 is too much, so 4 point, who cares? All right, so the focal radius is 2 radical 5. And then the foci are the points, but I'm going to draw the points before I say what the foci actually are. So let's go to the center, 3, 2. Okay, there's the center. And how do you graph a hyperbola? I need to make the rectangle first. R sub x is 2, so let's go 2 left and right. Let's go 4 up and down. 4 up and down, 1, 2, 3, 4. And let's go ahead and draw the asymptotes. The asymptotes go right to the corners of the box using the r sub y over r sub x. That's how you get the slopes, just like Algebra 1. Okay, and then you take your pencil. You have to know if it's going left and right or up and down. Since the transverse was x, you go to the sides of the rectangle and draw the hyperbola by following the asymptotes. Follow, follow. Nice and wide. Ooh, it's a wide one. Okay, let's also graph the foci. I know that the focal radius was 4 point something. You start at the center, and I'm going to go 4 point something. 1, 2, 3, 4 point something inside the hyperbola. Remember, as you pull that focal point out, the hyperbola gets really fat. So F for focus, 1, 2, 3, 4 point something, F for focus. So how did I graph those foci? How did I graph them? I went to the center, so I'm going to use this 3, 2, and then I went left and right. So I'm going to add the focal radius onto the x number. So it's 3, and then plus or minus 2 radical 5, 2. Okay. The only thing I haven't done yet is find the equations of the asymptotes, and to do that I need a point, and I'm going to use the center. And I also need some slopes. The slopes are plus and minus r sub y, which is 4 over r sub x 2. Oh, that's just plus and minus 2. Okay, I like to use point slope just because I think that's a little easy when I have a point and a slope. So asymptote number 1, y minus 2 equals m times x minus 3. No fractions, distribute, y equals 2x minus 6 plus 2 is minus 4. Is that true? Let's just look at the graph to make sure. Uphill line, a slope of 2. Does it really touch negative 4? Yes. Okay. Asymptote number 2 is the same setup here except the negative slope. So y equals negative 2x. That's going to be 6 plus 2. Does the other asymptote really cross at 8? Let's see, 5, 6. Yes, it does. Okay. Don't forget to also refresh your ellipse and parabola and the little circle shape. Good luck studying for finals. I miss you guys. Bye.